Let's take on this problem on chemical kinetics. The reaction rate, or R, tells us how fast a chemical reaction goes in units of molars per second. The reaction rate with respect to a specific chemical species X can be calculated by getting the difference of the initial and final molarities of X divided by the time t. The final molarity of iodide is 3.7 times 10 to the negative 3 molars, and its initial molarity 5.5 times 10 to the negative 3 molars would be subtracted from it, then divided by the time elapsed, which is 75 seconds. Evaluating this expression, we get a reaction rate of negative 2.4 times 10 to the negative 5 molars per second. A negative value for the reaction rate means that the chemical species was consumed. This makes sense because iodide is a reactant which is consumed throughout the reaction. The equation for the general reaction rate is usually presented using this equation with n, the coefficient of X in the balanced chemical equation, and an added sign multiplier which depends whether you're using molarities of a product or a reactant. If we look at this part of the equation, this is actually the specific reaction rate with respect to chemical X, right? Which means that if we use the concentrations of the reactant iodide, we can write the general reaction rate with a negative sign, iodide's coefficient 3Sn, multiplied by the specific reaction rate for iodide that we calculated earlier. This gives us a general reaction rate of 8 times 10 to the negative 6 molars per second. The general reaction rate is always positive and can be used to calculate and relate the different specific reaction rates from the chemical species in a particular reaction. Book your free demo session now.